So you want to deploy a token in the Solana blockchain. But first, you need to understand the following.
Net to dev.
It is very important for us to understand that there's a huge difference between the Ethereum-based blockchain, or EVMs, and a Solana blockchain. And most important is that when we interact with an SPL token, let's say we hold SPL tokens in our wallet, those tokens are not associated to the wallet address. Well, I'm going to say they're not directly associated. They're indirectly associated. The reason why I say that is because the way that we store data in a Solana smart contract, in the Solana network, is by usually generating an address that is associated to the contract and also the wallet, okay? In order for me to explain to you way better, let me show you the following. We are going to be transferring tokens from one wallet to another using Solana. If I have two wallets, let's assume this. We have two phantom wallets, and this is a known Solana browser-based wallet. So we have two phantom wallets. We have wallet 1 and we have wallet number 2, okay? Check this out. If I move tokens from one wallet to another, if I were to interact with an EVM-based blockchain, those tokens are associated directly to the wallet address, which means that on the smart contract, the amount of tokens are directly referenced to that wallet address. And that's how we store and that's how we know that that wallet has that amount of tokens. In Solana, every time that we interact with the SPL token smart contract, we are interacting with another pointer. This pointer is an address or it's an ID that gets generated the moment we initialize a first connection or first interaction with that smart contract. By the way, a Solana program is a smart contract. And when we work with the SPL token program, we are defining the name, we're defining the symbol, we're defining the supply, we are passing all those values as the token metadata in that particular program. No different from any other token smart contract. We are invoking indirectly a function that initializes that address in the program that is called the associated token account. That address is the combination of my wallet address and the token mint authority. The token mint authority is one of the program addresses that is involved or is directly associated to the function to interact with those tokens. But I am going to explain to you later what that is in detail. When I combine those two addresses, I am going to generate an ATA. And now the blockchain knows that the wallet address in combination with the smart contract ID or the program ID have to match the ATA. And that tells me that I am the owner of whatever asset it's that ATA reference in that program. Every time that I mint tokens, that I transfer tokens, that I receive tokens, they will be associated to that ATA. They're not associated to the system account. A system account is your wallet. They're not associated to that public key, the address of that wallet. Now, the moment I go ahead and I have those ATAs generated and stored in the smart contract, I will have the amount of tokens on that wallet associated to the ATA. When we initiate that ATA, what we are doing is a PDA. Every time that on that smart contract we generate addresses, if the address originated from a program, that address is called a PDA, or program derived address. So a PDA is an address that got generated inside the program. And now I can call that function in the smart contract and transfer that to a destination ATA. It is not being transferred to the destination system account, which is the wallet itself, the wallet address. Not only the source of that transfer, but also the destination of that transfer must have the ATA generated and associated to that wallet. One usual way is that during that interaction, if there's no ATA associated to that destination wallet, I can generate that on behalf of the destination address. I can pass that destination public key as an argument, and then the smart contract will know how to build that ATA. And after that, you don't need to initiate that account. It's already initiated, all right? Now I can initiate that transfer function. I can do that instruction to move those tokens from one wallet to another. On an Ethereum-based blockchain, usually the contract will have all the interfaces to do the transfer, to do burn, to do mint, and all that. In Solana, a program that you write to launch your own SPL token, it not necessarily has the functions embedded, or you are not writing those functions in the smart contract. Instead, what's happening is In Solana, every single program is associated to the main, or I'm going to say to the root system program, the SPL Token Program. Reference every time that we are going to be doing any execution in the SPL contract. In order for me to interact with that main, the root system account, my smart contract must have the SPL Token Program imported, so then I can call those functions. In order for us to write an SPL token smart contract, we have to work with a framework called Anchor. What is Anchor? Anchor is a framework that was developed to allow an easier way to streamline our instructions or our functions inside that smart contract. With Anchor, I can import crates. We are going to be writing this in Rust. Don't worry, this is your first time dealing with Rust. We all have a first time for everything, okay? So if you are going to be calling or interacting with that Solana program library token, your contract must import those functions that will allow you to interact with that. The Anchor language framework has that already for us. All we have to do is we have to make sure that we import onto the smart contract, and then we can write our code and call those macros, those types, those instructions in the code and allow us to do whatever functions in our program. When we build a smart contract, we are building a development environment for Anchor, okay? The development environment in Anchor, it's composed of a set of folders, and inside those folders, we have test folders with test scripts that we are going to be running on this tutorial. And also we are going to write a main contract file under the folder source. You are going to always look in the source SRC folder. Inside that SRC folder, there is a file called lib.rs, and that will be your contract file. Assume that we are going to write our first smart contract, okay? How do we do that? We open that folder, we locate that lib.rs file, and we start writing the code. The first thing that I'm going to do, I am going to be importing the Anchor language framework so then I can interact with the functions that I need. I am going to say 99% of the time you are going to have this line right here, the Anchor prelude, and then the wildcard at the end. What that does is brings to the program all the common functions that you need to import to interact with the Solana blockchain, okay? All the functions that you need to interact to do general things, all the deserializations, types, all the context, all the macros, all of that. The instructions, every general purpose item that we need in the smart contract, we will use that line. So you're probably gonna be using that for the most part. Now we initiate that smart contract by typing declare ID, and then we provide the address. When we initiate an Anchor project, that entire folder structure is generated with all the files that I need, and including a default lib file that we can write on top of it. Like we can just delete the whole thing and type on top of it. That declare ID is the address of the program. And you might say, well, I don't have the address of the program because I haven't deployed the program. How am I going to be adding that address on that pointer right there, right? Don't worry, you don't need to put any address. You do have to place placeholder. You just need to leave it as it is, or you can use the one that got generated from the initiate. So when you initiate that project, you type Anchor in it, then that whole structure gets created, and there's a placeholder for declare ID, but you just go back and you update that anytime that, for example, you do changes to that smart contract, because you can upgrade the Solana project, right? But you have to declare the ID. You have to type what was the program ID that you are going to be updating, okay? Don't worry, we'll get back to that. So now we go ahead and we initiate that smart contract. We type program, we initiate the type program, then we go ahead and begin writing the code. So we type mod, which is a module, then let's build a contract that is going to store names. We are going to be referencing the wallet address or the public key to a name, okay? So we're just typing a username, we're storing that data and referencing that to a public key or a wallet address, okay? So we're going to be typing pub mod store names. That will be the name of the program or the contract. We are going to be typing function, and let's build the function to actually do that store names, okay? The function is going to be called save_names, okay? The first thing that I'm going to declare as the argument for that function is very important. I think it's one of the most important things that we need to understand in Solana. In an SPL token program or any other program that you write in Solana, you are going to be working with context. Context is basically a way for me to group a set of data, set of attributes. I'm going to call this set of attributes that I am going to deserialize. Deserialize means that I'm going to be extracting from a particular type. So in this case, if I want to interact with accounts, I have to tell hey, enumerate the items inside that context, okay? So the way that we write a context is using a struct, okay? So with a struct, I can define all the elements inside that particular context. And what I'm going to do, I am going to be passing the entire context as one of the arguments, okay? But I am not only grouping a bunch of pointers in one context, I am also building some functions inside that context, some instructions, which then I can import into another function and then make calls. I am going to be typing the context name and I am going to be passing that as the argument. We define the context. In this case, I need to reference the wallet to the name that I'm going to be storing so that I point the name to the wallet address or the public key. What I have to do first, I have to define that public struct. I'm going to be bringing that deserialization from accounts. If you remember, we imported the anchor language, Prelude. So that includes all those base functions, base instructions, anything that is commonly used in the anchor language framework, it's inside that Preludes. And then from there, the asterisk is a wildcard, which means grab everything that you have. Then from there, import that into the contract. So when I do that, I am going to build that struct that already I have declared that I'm going to be deriving the accounts, because I'm going to be deserializing accounts by breaking down the parameters inside account and passing data or arguments to those parameters, okay? So the first one is going to be payers, and I am also going to say that accounts is immutable, meaning that that type for payer is mutable, right? So we got the type, we got the actual parameter, and that is going to be mutable, okay? We are passing signer. Signer is whoever made the call to that smart contract. Signer, which is another item that we are importing with anchor lang. We have that available in the contract. We are going to be passing that, okay? So everything that got stored during that execution regarding the signer, we are passing that as argument, okay? Then we go ahead and we initiate, where we generate that ATA or that associated token account. In this case, we're just initiating that so then I can reference the value of the wallet against the name that we are going to be storing, okay? Then we are going to be passing what? Who is going to pay for that transaction? That's another thing that is very cool in Solana. In Solana, I can delegate to whoever is going to pay for that transaction. Usually the signer is the payer, passing what? The payer as the signer, okay? Then we are going to be defining the space that we are going to be allocating in that smart contract for every single wallet that decides to store data in that smart contract or program. In that space parameter, I am going to be defining the space itself, which is that 8 value right there. It's unsigned or signed 64. And if you want to know the type, you go into the anchor language documents and you are going to see that the 8 value means it's U64, I64, which is signed or unsigned integer. Next, we are going to be passing the struct that is going to store or obtain all that data and classify that in the smart contract. We haven't built the struct yet, but we will do in a second. We are going to be writing a struct called name data, okay? Inside that struct, we are going to be classifying those names. We're going to be storing those names. And finally, we are going to be passing init space. So init space is another type of constraint that I can use in that smart contract to initialize the space that I'm allocating for every single wallet. I'm not only giving you that space in the smart contract or in the program, but I'm also like pre-writing that space, or I'm pre-allocating the space for that particular account. That doesn't mean that I already have the space allocated or I already used the space. It's only to initiate or like to enable that space. I'm going to say enable is the right term. So it's to pre-enable that space on the program. Then we are going to be creating another parameter called name_data, in which we will then pass the actual value of that data. Whatever value we obtain when that wallet made the call, we are going to be passing that on the context, okay? And what information am I going to be passing? The account, as well as the data that was allocated for that account. So we need to point the value of that account so then we can reference that account to the actual data. And we said that we want to store the usernames on that smart contract. So the user must be passed by the wallet or by the caller. Then we will reference that on the smart contract, okay? And finally, the system program. We are going to be passing the value for the main system program, part of the elements in that context. Once we are done with that, let's go ahead and write that struct to store the data, name data, okay? First thing I'm going to be passing is going to be the length, the maximum length that I'm going to be allowing, which is 50. So up to 50 characters, I am going to be allowing that to be stored per user. So that means that a user must not go past that amount. So then I am controlling the amount of space that I'm going to have available per user or per wallet, okay? Then we pass the value. Now that we have this, we can effectively go and add the context as the argument, and then the next is going to be an argument called name, and it's going to be type string. When the user hits that function, the context already knows that it has to grab the information about that wallet to initiate that account, and it's to generate the address. It has to map, or it has to point the address to the wallet, to the space, then associate that space to the wallet itself. And then when the user provides that string value, we pass that on to the struct. So you can see that we added create name, we connected that to the context that we built below, we added that as an argument. Now we pass also the name, and under the function, I can call the context that I imported because the user is giving me the string value that I have to pass and I have to store in that, which means that the context dot account then dot name underscore data is where I need to be passing that argument into the struct called name data. And that's how we store that value to that wallet, or we reference the value to that wallet. Don't worry, we are going to go all in detail in how to build a full-fledged SPL token smart contract. Once we write that smart contract on the project, on the Anchor development environment, we can type Anchor build that compiles that smart contract. Then we type Anchor deploy, we press enter, and we are sending that to the network, in this case, either to the mainnet or the DevNet. We are working with the DevNet because we are doing this as a test. We are effectively deploying that program in the Solana blockchain. Once we do that, we obtain that program, and finally, we can run a test. So let's run a test. What I'm going to do, I am going to be passing John as the name of the wallet that is going to be interacting with that function. We should be storing John associated to that wallet address and passing that to the program. And finally, we need to check if that value is stored in the program. How do we do that? We write a test, we run the test using Anchor test, and if everything goes well, boom, we have the data successfully stored in that program. The end goal in this video tutorial series is to write an SPL program. We will launch our own SPL token, and we will also add the Metaplex metadata on that program contract file using the Anchor language. We will also work with the Metaplex instructions, so then we can also add metadata to that token and show that token logo, show the token symbol in our block explorer. Alrighty, I hope that you enjoy this initial tutorial. On the next video, we are going to be building that Anchor development environment, and we will test our first smart contract before moving forward with the SPL token. Don't worry, if you still feel lost, I know that by the end of this tutorial series, you are not going to be lost. You got this.